Hello and welcome to another video. So this time around, as the title suggests, this is a bit of a behind the scenes look at one of the projects that I'm currently working on. So what I want to do is, in videos like this, show you a bit of the stuff that I'm working on for the project, and also, where possible, share a bunch of the code for it. So let's take a look at what I have. So this is a system where it's a procedurally generated world. It's using individual tiles, so we can see the actual individual tiles that are being generated here. So it's procedurally generating terrain, but saving that as an actual mesh. And the actual generation itself, we can see, we've got this sort of drier, in this case it's referred to as the forest mountains biome, but it actually has support for other biomes. So we've got stuff like a desert biome, which if I add in a couple more tracks, and it attempts, where possible, to sort of blend the seams with the tiles. Now, we can see the seams fairly easily from this angle, but the actual game will be taking place way, way, way lower down, like much closer to sort of this angle. So there's going to be a lot less capacity for people to be able to actually see any of those seams. So it is doing some smoothing there. It can turn left and right and go straight ahead. So this is using in part some of the techniques I used in Let Me Tell You a Story, for being able to ensure that it can't loop back on itself. So that'll be part of the code that I share there. But the big thing is we've got all of this stuff for the different biomes and being able to generate those and having those blend together. And we'll bring in then the Rocky Mountains as the final one. So multiple different types of biomes. It's able to take these winding paths, guarantees that it won't overlap. But I did a couple of unique things with how I actually generate these, and in particular for some of the ones like the desert and so forth, there's a lot of sort of key things I did with this. So if we take a look at what's actually in a biome, it's not really too much to it. Has some base color stuff there it can use, has a scale for the maximum height, so biome to biome. So there's an overall world maximum height, but then biome to biome, I control how much of that maximum height they'll be able to achieve. And then we have these Procgen rules. So this is using the approach I've done before of a prefab. Different approach slightly this time is, rather than being multiple, I'm using them all just on the one prefab. So the Perl and noise, bit of a change with this in that the configuration for the different octaves. So with Perl and noise, we often run multiple passes of it. So I wanted to be able to do that. And what it is you configure multiple octaves and you can configure the amplitude and the frequency independently for each one. So it gives me a much more fine-grained control. The smoothing, the blur that happens, is also something that is variable. So the kernel size, so when we're talking about kernel for something like blurring, we're talking about the area that it can blur, the size that it's grabbing and averaging. That actually is able to change, and in particular, it's adapting with the height. So things that are higher use a small kernel, so they won't change as much, whereas things that are low down use a larger kernel, so they'll smooth more. What that means is you take something like the shape of a mountain, the peak can be preserved and still kept fairly sharp, but then as you get lower and closer to the ground, it becomes smoother and flatter. So it gives some nice variation there with that. Terrain painting also has some stuff there for using Perl and noise. But let's take a look at the actual biomes. So similar approach I've used when working with terrains. The generation goes through the biome largely. So that's modifying the height map, has a separate interface for the terrain painting. As I said, with the blurring, this is what we're talking about, where it goes through and it smooths it. But if we're using an adaptive kernel, then before it goes and does that sampling, it goes and adjusts that kernel size, lerping based upon the height relative to the maximum height that's permitted for this biome. And then applying it is again a lerp to it. All of these modifiers support intensities, so the higher the intensity, the more that modifier is going to be able to impact and change the terrain. So, okay, that's that part of it. But then if we take a look at the core sort of setup, so when I mentioned being able to ensure that it doesn't overlap, this is how I go about this. So we have these key variables here. Number of left turns permitted, number of right, number of straight and max straight sections. And so left and right being set to 1 is very intentional. That's actually crucial from the beginning. Number of straight sections, that just ensures how long we can have a straight section before it will enforce that there needs to be a turn. How this gets used is what we do is based upon whatever the current number of left, right, straight sections are permitted, those get added in to this track types. So we have an enum for it. Then we can, based upon that, pick one. So we do our random picking. And then what we picked changes then how those number of entries to put in change. So if we turn left, then we decrease the number of left turns permitted. But on the opposite side of that, we increase the number of right turns permitted. Straight road sections can be, shouldn't actually be straight roads. So straight sections permitted, that can increase, but it can only increase up to our threshold. So that way then we don't have that balloon out to be too large a value. Right turns are similar. Straight sections are also fairly similar. They work a little bit differently in that when taking a straight section won't go and affect the left or right turn modifiers. Those counts are linked together, whereas the straight section just decreases the number of straight sections we can use. And we map out the directions. So with Let Me Tell You a Story, I had pre-made tiles and I would randomly select from one of 3 tiles and place then a building. And alongside that, a bunch of decorations there for the street that could be placed down. So with this, that wasn't a viable option because Let Me Tell You a Story was something where a single level was maybe 5-10 minutes at most. This is intended as something that we're talking half an hour, possibly longer, for the playtime. So authoring enough tiles like of that was not really going to be feasible. It's an area where Procgen, procedural generation, is going to work a lot better for that. So that's why what it does is it stores the direction. So in terms of with that, those direction options, if we take a quick look, we can see what the directions have. So that's northeast, southwest. And just I set up some helpers to make it easy of like, okay, well, if I'm heading north and I do a left turn, well, now I'm heading west. And same for right turns and opposites. So that lets me work out what the current direction is, what the next direction is going to be. And I work out also the step. So one of the things I do for anything that's using Perlin noise, that's generally changing based upon the grid location in the world. Just so that they can, to try and help it, that they can be a little bit nicer in terms of blending between the sections. So in terms of the actual generation of the tiles, the biome handles then the height generation, and that's using those things like the Perlin noise that we saw. Then we need to flatten it. So we actually have to make a track area, and if we take a look at the manager, it has this track fade curve. And this fade distance, that's controlling how large a section in the center is flattened. So then how that flattening works, if we take a look, it needs to check if it's curved, because that's a starting thing. Because for the sections that are straight, that's easy. We're either heading vertically, horizontally, we can easily check the particular sections that we're heading between. But for when it's a turn, we've got essentially a quarter of a circle that we need to be flattening relative to. So there's a couple of extra things we have to do in that case. We work out reference points, and that's again based upon the entry and the exit side. And then we apply the flattening. So we need to work out the distance from that track line from any point to that track line. So we go through, we're evaluating every point, and we work out the actual distance because we've got the vertices, and we get rid of the y component, so it's only in 2D. Effort is, within the actual reference point, we ignore it. Otherwise, what we do is we then get that distance, normalize it in terms of working out then the actual point on the track, get the distance, and then we're able to perform the fading. So, okay, we've generated the faded area then. Blending with the neighbors is a challenge. We blend height first because the actual blending of textures has to happen later. So for blending the height, if we take a look at that, what it does first is it checks to see if we've got tiles to the north, east, southwest. So we've got those stored in a dictionary so we can easily look those up. Then for doing that blending, first thing we do is we take the vertices on the edge of that other tile and we apply them. We essentially stamp them to the corresponding vertices on our tile. So, okay, source tile, those vertices get copied over. Then that transfer, it's a fairly bit verbose for the setup, but that allows us to use the same loop regardless of what type or orientation of tile it is that we're joining. Could be a curved one, could be a straight section, could be one to the northeast, southwest, doesn't matter. This loop works the same. When it actually is then doing the smoothing, again, we do a bunch of that setup stuff so that we can have the same loop apply. And what it does is it starts at those edge vertices that we stamped in, takes one step closer in, and then it does a loop from what the edge vertices, between what the edge vertices are and what the current vertex is, just to try and have it be a smoother transition there with it. We do a similar thing when we're doing the color blending, checks the neighbors, transfers those edge colors, and then transfers for doing the actual smoothing, and it's largely the same logic. But we do it quite a bit later, and the reason for that is because we need to generate this mesh. Because one of the things we need for doing the painting is we want the normals, because the normal information gets used. If we take a look here for the slopes, slope here where it's painting based upon the steepness, that's using the angles. So what we do, firstly we generate UV coordinates. I'm not really using them at the moment, but it doesn't hurt to generate them, and then it gives me something that is useful there if I need to generate a texture, something like that. At the moment I'm using vertex colors, but by generating the UV coordinates I could then use just actually generate a texture if I wanted for working with the setup there. So this just gives me a good option. Transferring then the vertices. So one of the big things is, so when we're with the default mesh format, you indicate triangles. So that means for every square, essentially, there are 2 triangles. And that's why I don't go to the very last vertex, because I'm always doing +1 for these. Now the order of these matters, because it determines which side you'll be able to see this from. Because if I run this, and then we'll go just to any one of these tiles, I can see it from this side, but if I go underneath, then I will not be able to actually see it because it's facing the other way. So if I get the order wrong for this mesh generation, in terms of getting these around the wrong order, that would actually result in it essentially being flipped there. So the winding is what we refer to. That's important. The mesh format. So in Unity, if our mesh is going to need more than 64K indices, so 65,535. If it needs more than that, we need to change the index format. So that's an important thing. We transfer over vertices, the UVs, we set the triangle info, recalculating everything, because then I can do the terrain painting so that I've got the normals there. And so with this, one of the things I also wanted to really be able to control, and you'll notice, is I can easily just change the resolution. And this was a very, very deliberate thing, because at this stage, I don't know exactly the resolution that I need. These tiles are 400 by 400 meters, but I wanted to be able to easily control what resolution they get generated at, because performance-wise, I need to have a lot of these. As in, I'm expecting to need probably around 15 to 20 of these on screen at any point in time, and there being a lot of other stuff. So it's 15 to 20 of these with then also decoration in the terrain, other things in the environment. There's a lot of other logic that I need to have happening. So this cost in terms of vertices and tries is something I'm really keeping an eye on. And because it scales up pretty rapidly. So that's at 64 by 64. If I go to 128 by 128, and we'll run this. So with that, it doesn't increase by 2 because we haven't doubled the resolution exactly. We have doubled the numbers that represent the resolution, but that actually means we have 4 times the amount of data. So that means just going up to 128 by 128, so each one of these being a 4-meter spacing, results in a significant increase there in the amount of data. And it also, conveniently, I want a very faceted looking terrain. I want it to actually not look blocky, but I want it to look so that it has a good level of faceted aspect to it and some variation in the shading, which you can see we get to 256 by 256, apart from the fact that it takes significantly longer to generate because it's processing 4 times the amount of data. It actually doesn't give the visual effect that I'm after because it's too smooth. So that was a really nice discovery with this, that even 64 by 64 actually looks pretty good. And that's been a really great discovery with this, that, actually, because I was thinking I was probably going to need a resolution of, a sort of 1 meter there, so something more like around, over 256 by 256. And the reality has been that actually I don't, because this sort of feels about right scale-wise. And for context, this is going to be a first-person game, and this is a very, very, very rough prototype of one of the sort of vehicles you would be on. So we can see kind of the scale when we look at this. It gives us, even at that facetedness, works out pretty nicely. And didn't need to do anything too complex shader-wise. So the shader, it does use a custom shader, and I am using Shader Graph because I'm doing all of this in the universal pipeline. There's not too much for what it's doing. It is calculating world normals and feeding that through. That's something that probably could get away without doing that now, but having those world normals in there was giving a nice effect, and it uses the vertex color. So it's a really simple shader at this stage. There might be more things I end up adding to it, but for now it's working pretty nicely, and I'm happy with how that's actually looking. So the final sort of bit, if I run it, that we'll be able to see, and this is something that I will be talking about a bit more at a later stage, is with the tracks selected, we get this magenta line. So this is going to be the actual reference line for the track. And although the line, we see it looks very smooth, it's actually 1 meter spacings there. It's drawing this line at 1 meter segments. And the idea is going to be that this track is something that we can then follow, these vehicles can follow along. So in the next video, what I want to be showing off there is talking about, okay, how am I doing that positioning of something along this line, and how am I actually having it move along the line? Because with this being procedurally generated, setting up a Cinemachine path isn't as much of an option with this. And also because I want to have the flexibility to have more shapes than just a left turn and right turn, things like that. So that means that I needed to procedurally generate this path and then place it. So it actually is placing that carriage on the particular area here. And it can place it on curves and align to curves. Part of the reason the tiles are 400 by 400 meters was to actually allow enough of a length. Because if we look at the size relative to the carriage, it allows enough of a length that we can actually have multiple of those carriages easily align and move around a curve, which is going to be a really cool thing to be seeing, and will be something that I'll hopefully be able to be showing off in the next video. Thanks folks, I hope you found the video interesting. Now I have actually made a bunch of the code for this available. I'm not making the full project available, but what I've done, and you'll find in the description below, is there are link to a gist that has the individual code files for a number of the key systems. So it's not something that's fully standalone, but it gives you an overview of the sort of algorithms and approaches that I'm using there, and gives you some code for some of the key things like that adaptive blurring, like the mesh generation, like the terrain painting setup there. So you'll be able to see all of those. And that's code that you're very welcome to use in your own projects. And if you've got questions, chuck in a comment below. If you found the video helpful, do chuck in a like and subscribe. It's something that really helps out. It's really appreciated. If you're looking for other ways to support the channel, I've got a Patreon as well, and the link to that you'll find in the description below too. But until next time, bye.